everyone, just checking in with this. This is number 21 from section 8.2, which is on hyperbolas. So our goal for these ones are to write it in standard form, and then you can identify all the stuff. So writing it in standard form means that we want it to look like something like this. And so we're going to have to complete the square twice. Notice that it has minus in the middle. So the next thing that we want to do is work on completing the square. So let's look at the x's first. We take out -4. We leave x squared minus 6x, because that would make the positive 24. And we're going to add 9 to complete the square. That's taking the middle half of it and then squaring it. So that's going to be 3 squared, which is 9. Then we're going to write minus 9 right next to it, just so it doesn't change the value of the equation, but it's going to just make it look a little bit different. And then we're going to do the same thing with the y's. So we're going to take out plus 16, and it's really just these coefficients in front of our squared term. So when we take that 16 out, we're going to be left with y squared minus 8y. Again, here we're going to want to add and subtract something. We're going to add 16, because again, half of 8, or 8 divided by 2, however you want to write it. And then squared would be 4 squared, which is 16. And then we're going to write minus 16, again, to undo that, just so it doesn't change the value. And we still have plus 156 equal to 0. So now the whole point in doing that was to make a trinomial that factors nicely. And this will factor to x minus 3 squared. And this one right here will be y minus 4 squared, since 4 times 4 is 16, and then going back to the other one, 3 times 3 is 9. Now the other parts still continue on. We have -4 still hanging out. We have the 16 still hanging out. But we need to do something with this minus 9 and minus 16. It's inside the parentheses, so it actually has to distribute by that lead coefficient. So -4 times -9 is actually a plus 36. There was a plus sign here. That was just the plus 16. And 16 needs to multiply with that minus 16, which will make a negative 256. And we still have that 156 equal to 0. So if we combine together all of our like terms, we're saying that 36, the negative 256, and the plus 156 all have to go together. So kind of easier, negative 256 plus 156 is negative 100. So we'll be left with 36 and negative 100, which will be a negative 64. So I'm going to rewrite everything that I have here. I'm going to rewrite 16, y minus 4 squared. And then I'm going to put that 36 minus 100, we said it was negative 64, equal to 0. Now our hyperbola, kind of going back here actually to the very top, has to be equal to 1. And notice there's no coefficients in front of those parentheses. We have all of our numbers in the bottom part. So if I look at this form that I have going on over here, I need to get rid of that -4, the 16, and then the 64 also. I'm going to start by moving the 64 over. So I'm going to have -4 x minus 3 squared plus 16 times y minus 4 squared equals 64. Now I could divide that by 64 to make the 1 that I need, but then each of these terms has to also divide by 64, but that's where we end up getting those fractions. The 4 over 64, if we divide both those by 4, we're going to end up with a 16, and then 16 over 64, those reduce to make 4. So then I'm left with negative x minus 3 squared over 16 plus y minus 4 squared over 4. And we're almost done. Now the hyperbolas, they normally have the minus right in the middle, and our negative term is actually our first term. So we're just going to put that as our second, which means the y minus 4 will be written first. We want that positivity in the beginning. And we'll have minus, x minus 3 squared over 16 equal to 1. So that should be what our standard form for our hyperbola looks like, and then you guys can keep going. Because our y is first, we know it's going to be one of the hyperbolas pointed up and down. We know that our center will have a 3 and go up 4, and then again you could keep going. Hope that helps.